Okay, so for part A, we need to find the partial derivative with respect to x. So what do we keep constant? Y. Because z is a function of x and y. Since we're doing the partial derivative of z with respect to just x, we keep y a constant. So the partial derivative is equal to 1 plus, now the y squared acts like a constant, so we just write y squared. And we still need to take the derivative of the function of u, since u is in terms of x and y. So we can write f prime of u times du partial derivative u dx.
Those are partials.
Yeah. Because it's like the chain rule. We take the derivative of the function and then the inside, so the function times du dx. So this is equal to 1 plus y squared f prime of u. So what would the partial with respect to x be? 4xy. Because the y acts like a constant, just like the 2, and the derivative of x squared is 2x. So it's 4xy. So that's equal to 1 plus 4xy cubed. And you can write out f of 2x squared y, or f prime of 2x squared y, because that is u. But you don't need to. You can just write out f of u there. Any questions on that? Because we don't know what the function is. We just know u. So we can leave it as f prime of u there. Or we can plug in what u is by putting in 2x squared y. Did that make sense? Yes, guys?
Yay.
Okay.
Good.
Wait, why do you have to do a product rule for
Right here?
Yeah.
We're keeping what constant?
Are we keeping y constant?
Yep, since it's with respect to x.
If it's not mentioned, do we keep it constant?
This is the partial derivative. So in a partial derivative, you keep it constant.
Okay.
But, and I'll get to the other ones where it's like they include all the parts. But
Who hasn't had the signage?
so what is constant in part B? The x. So it's 0 plus what?
2y. Oh wait,
Exactly 2y times f of u plus y squared times the derivative of the function, which we can leave as f prime of u, times the partial of u with respect to y. So that is equal to 2y times f of u plus, we found, so what is du dy? The partial,
2x squared.
2x squared. We plug that in here. So then what do we get? 2x squared, y squared, f prime of u, and that is it. So the only part was knowing which to keep constant, since we're doing it with respect to x and it's a partial derivative, we keep y constant because we're only taking the derivative of x portion, essentially. And in this, we do the same with this with respect to y. Any questions on these two? No? Good. That was pretty easy compared to. But once you understand what partial derivatives are, all of it is the same. Okay, guys. For number 8, we are given the function f with x comma y, and we need to take the derivative, or we need to find dy dx by taking the derivative of the entire thing. So this problem is trying to find y prime, which you guys have done before. So let's take the derivative of this entire function, or else with respect to x. So it's not a partial derivative. I don't know if I made a partial sign or so this is unclear on here, but we do the derivative anyway. So what would the derivative of the x cubed be? And they tell you to do it by taking the derivative, so you can't use the theorem. On problems, they will tell you to use the implicit function theorem, and this one they tell you to do it implicitly. So this means you need to write, do it manually.
Is it like calc 1 way? Is that what that
Yeah, calc 1. So 3x squared minus the derivative of cosine of xy is what? Sine of xy times the derivative of the inside, xy prime plus y times 1. So with this, again, we need to do the product rule. So x squared times 3y squared y prime plus y cubed times 2x. Then what you do is you bring all the terms that don't have y prime to the other side, and all the terms that do have y prime remain on one side. You factor out y prime, and you solve for it. So, have you guys copied this? Or understand it? So we have on the left side 3x squared, or let's do the y prime on that side. Y prime times x sine of xy minus, no, it's not negative, 3xy squared equal to 3x squared. Y is what minus?
3x.
This?
Why is that? be negative and the other one should be positive. And that should be negative 3x squared on the other side.
Let's see what they did.
You just write down to the other side.
They
It's like
have
right
the
now, you're not negative, then you write down to the other side.
well, yeah. Essentially, this is the side that's this side, and they brought the stuff to the right side. I just started writing y prime on that side. It's the same thing. We can do it either way.
It's okay. Just keep doing it.
No, for people watching, I'll do it first.
What?
I'll start writing 3x squared on this side, because people might be watching and be confused. 3x squared plus 2xy cubed minus y sine of xy equal to, so we brought everything with y prime on this side and factored it out. We have x sine of xy minus 3x squared y squared. Does that make sense? So then we solve for y prime by dividing that down. We'll have 3x squared plus 2xy cubed minus y sine of xy divided by x. We can factor that out. And the quantity of sine of xy minus 3xy squared.
Is it 3x squared?
I took out an x to simplify it. Any questions on that? So this is what you did in Calc 1. Okay. For part B, we have to use the implicit function theorem. So what is f of x? That is taking the derivative while holding what constant?
Why?
Y. Because it's taking it with respect to x. Okay?
Yeah.
So what would it be?
3x squared
Yep.
minus
Y sine of xy. Because since y is constant, we can, the derivative of the inside would just be y. Plus 2xy cubed. Now f of y, what are we holding constant?
x.
X. So we have 0 minus x sine of xy plus 3x squared y squared. So then the derivative of y with respect to x, which is y prime, is equal to, what is the formula?
Minus f
Negative f of x over f of y, which is that. And your answers should come out the same. If they don't, you did something wrong. So that is 3x squared plus, or a minus times 3x squared plus 2x y cubed minus y sine of xy divided by 3x squared (3xy squared) minus sine of xy. So I took out an x here as well. And here we have sine minus 3xy squared, but since we have a negative sign in this function, it's the same thing. You can write it either way, like that or that. guys good? Good to move on? We are given for 9 a function of x, y, and z, y squared e to the 3z, tan of 4x. We are told that x is equal to 3t plus cosine of t, y is equal to t cubed plus e to the 3t, and z is equal to t cubed plus the natural log of t. And we need to take the derivative of f with respect to time. Now, f is not a function of time, but x, y, and z are. So we need to do essentially the chain rule. And another way to think about it is the tree diagram thing they showed in class. But each of them is made of 3 components. Component involving x, y, and z, and we add them. Okay? So what would I write here? So what would be the first thing? I'm just going to put f. F of what? X. Then what? Dx dt. See, at that point, okay.
Is it? Oh, wait, no, it is full. You're right.
It is full.
It is full. Not down there.
Since x is just a function of time, the full derivative is the same like as a partial. Okay. If x was a function of say time and s, then we just take it in terms of time. Okay. So say x was equal to 3t plus cosine of s, right? We only care about t because what we want is the derivative of s with respect to x times the derivative of x with respect to t, so that in the end we get df dt, right? That's what we're looking for. So if x was part of something with an s in it, you do a partial derivative just taking with the time. And then,
Just 0. Cosine of.
yeah, no, so yeah, this would be a constant. The derivative of a constant is 0. Yeah. So, and then it goes the other way too. If we wanted with s, we'd do it with s. They wouldn't do anything like that, I don't think.
Never underestimate.
Okay, so plus partial derivative with y times dy dt plus f of z dz dt. So now let's just fill in the blank. What is the derivative? Okay, so if we're taking the derivative f of x, what do we hold constant? Y and z. So what would we have right here? So let's write out y squared e to the 3z, because they're constants. What is the derivative of tangent of 4x?
4 secant squared.
Yep, 4 secant squared 4x. Now we need the derivative dx dt. What would that be? 3 minus sine of t. So that's the first part, and we just keep going. If we're doing f of y, what are we holding constant? X and z. So we have 2y times e to the 3z times tangent of 4x, because all of them are constant, and we have 2y there. What is the derivative of, dy dt? 3t squared plus 3e to the 3t. Moving on to f of z, we hold x and y constant. So what do we have?
3y squared times 4x to the 3z.
3 times e to the 3z is the derivative, times y squared, and times tangent of 4x, because that stays constant. The derivative of z with respect to time.
3t squared plus 1 over t.
So it was essentially fill in the blank once you realize this part.
Why is it in this part things don't go to 0, but then in other parts things go to 0?
Because we're taking the full derivative
Oh,
and we have components from each part.
easy.
Yep. But sometimes they like mix up the notation and yeah.
What is like FC means? What is FC mean?
So all of these fy, fz, fz is the same notation as taking the partial derivative of z, sorry, of f with respect to z. Okay? Since we're doing the partial derivative with respect to z, that means the rest of the variables, in this case x and y, they're constants. And if we were doing a full derivative of it, that's when we have x prime and y prime, because they're independent variables. That's why. Okay. Moving on.
We're just supposed to leave it looking ridiculous?
Yeah.
Okay.
You can take out a y squared and z, but that's acceptable.
Man, that's gross.
10 is just like 9. We are given a function u v w, f of u v w. We have natural log of w plus cosine of u v. So, okay, in this time, we do have u is a function of 3x squared plus 4y. V is ex squared plus natural log of y. So they are now with two variables. And w is tangent inverse of x and y. But we want just the partial derivative with respect to x. So for that one, we had a full derivative sign here because x, y, and z are all just functions of t. Okay? So partial derivative or full derivative is the same thing. In these parts, we needed the full derivative sign because they're just a function of t, right? Partial derivative and full derivative are the same thing. Now in this question though, u, v, and w, as I mentioned before, with if it was made of t and s, u, v, and w are made of x and y. So if we want a derivative of f with just respect to x, ignoring y, we need to we show the partial derivative sign, okay? Because we're not looking at the y component. So in this case, the partial derivative of f with respect to x is f of u times the partial derivative of u with respect to x. Okay, we're only looking at the x component, so we only want the partial derivative with respect to x plus f of v, partial derivative v with respect to x, and f of w, partial w with respect to x. they haven't taught you guys how to do the full derivative, I don't think, of f. No. With because you need to take a derivative of x and y, but I don't think we've learned anything like that. So we are going to ignore what I said. Because I think if we were to do that, we'd add them or something. But we'd add with respect to x and add with respect to y together, apparently. But never mind. We're doing it with just respect to x. And then it's again fill in the blank. What is the partial derivative with respect to u? Negative v sine of uv. Six x. That's du dx. Is partial. Plus what?
Negative u sine
Negative u sine of uv. We're not even looking at the natural log of w because in all of these it's kept as a constant, so the derivative goes to 0. And what is the partial of v with respect to x?
2x e to x squared.
Yep. Plus the derivative of partial derivative with respect to w.
1 over w.
1 over w. And what is the derivative of tangent inverse with respect to x?
1 plus x times y.
1 over 1 plus xy quantity squared, and then the entire thing times y, which is the derivative of the inside. And in this one, you do have to simplify it.
Why? Why did they say that? They never said it.
Let's see what they simplify.
Do you substitute?
Well, not really. They just wrote it. So you do need to write it neater, like minus 6x, all of that, minus 2u e to that 2x times sine, plus y over all of that. Should I write that out?
Yeah.
I will just make adjustments there.
You have a question, sir.
Do you plug in for U, V, and for W?
We keep them as variables. Yeah, that would make it an even longer answer. You don't need to plug them in. So minus 2 xu e to the x squared sine of uv plus y over w times 1 plus x squared y squared. So the reason in this one we didn't simplify is because you would have had to multiply 3 across, sine of t across, and it would be way longer than simplifying this small step. So try to go as far as you can. Or you can ask them during the exam if this is simplified enough or something.
And then Dr. Tyler will be like, well, what do you think? And I'll be like, alright.
Are you guys good with it? xyz plus y squared plus yz, natural log of x equal to 10. Y is a function of x and z implicitly. So we have to find dy dx the partial of y with respect to x holding z constant using the implicit function theorem. Okay? So just we have to find that with the implicit function theorem. So in essence, this is our function f of x comma y comma z equal to x y z plus y squared plus yz natural log of x. If we're doing f of x, we are holding y and z constants, right? B
YZ,
plus
YZ over X.
yz over x.
This with a C.
Okay.
Yes,
Is that fine?
I think so.
So these were the constants in front of x, and these were the constants when we took the derivative of x.
Alright.
F of y is what?
X
Z
plus
2y
Z and X.
natural log of x. Because we held x and z constants. Yep. So now the partial derivative of y over x with respect to z constant is equal to the negative, and what goes on top?
X.
F of x over f of y. It's like the bottom and the top. Like the bottom goes on top. So you could have done it with z instead of x. So we have negative yz times 1 plus 1 over x divided by xz plus 2y plus z natural log of x. And we can multiply top and bottom by x over x. So you get negative yz times x plus 1 all over x times the denominator xz plus 2y plus z natural log of x.
Well, they take off boys if we don't multiply by X. It's not really wrong.
I don't know. It's always weird trying to figure out how much they want you to simplify. But here we have a fraction in the top, so that's a clear sign that we should try to simplify more. Because it doesn't look good when we have a fraction on top of a fraction. So if you have something like that, you should simplify it. They might take 1 point off or something. Make sure, like, when you are simplifying it, you don't mess up and, like, not multiply an x in the denominator or something. Because then you'd lose more points than one. Okay. Any final questions on that problem? No? Okay. So now in this problem, we sort of use everything. U is equal to the function f of w, comma, x, comma, y, comma, z equal to cosine of wy plus wx squared yz plus sine of xz. So the constraints on u are w squared x squared plus w xy plus y squared equals 5. This means that these three are related to each other. So if you change x and y, it changes w in order to keep this equation valid. To find the partial of u with respect to x, what do we have? F of w, dw, dx, plus f of x. Now dx over dx, that's just 1, plus f of y, partial y, partial x, plus, and also with z, you can leave your answer like that, or you can make this a 1. Okay. You guys good? Part B, we have to find partial of u with respect to x holding y and z constant. Okay? So if y and z are constants, that means that in this equation, we have no derivative with y and z, right? Because they're not changing. So both of these go to 0. Did that make sense? Because we're not changing them, they're just constants. So here we can rewrite it as f of w, partial of w with respect to x, holding y and z constants, plus f of x plus 0 plus 0. Now we need to find this right here, okay? They show the work involving, so they show it on here implicitly. It doesn't say that you have to do it implicitly, okay? You can do it using the function theorem, okay? So for part B though, I'm gonna do it the way they did it. So we have our function, we have our constraint w squared x squared and all of that, and we're taking the derivative with respect to x. So I'll rewrite. Taking the derivative with respect to x. So first we have 2x times w squared plus 2w, or holding like the product rule, we have x squared. What's the derivative of w squared? What's the derivative of w squared? So we're doing the product rule right here. Okay. 2w times the partial of w with respect to x, holding y and z constant. So this is the same thing as w prime. So all of this step was doing the product rule on w squared x squared. Here we took the derivative with of x, so we have 2x times w squared. Here we took the derivative of w times x squared. Okay. Plus, we have wxy. Y is a constant, so we can take it on the outside. W times 1 plus x times the partial of w with respect to x, holding y and b constants, because the derivative of w is just 1. But we still need to multiply by essentially w prime, plus 0 equal to 0, since the derivative of y squared is 0. Hence it's a constant. You guys good with that? That was pretty long. So then again, we have to isolate stuff. So on this side, we have rho w over dx with y and z constant times 2w x squared plus x and y. Don't forget the y out here. Equal to minus 2xw squared minus wy. We brought them to the other side. So on this side, we took out w prime essentially, and then on this side, we brought everything without it to that side. So that included this term and these two. And to find this now, we just divide it so that it should be under there. We're still not done with that problem, since we need to find the derivative of u partial.
The fx, w.
We do need to find those components as well, but the overall question is the partial of u with respect to x, holding y and z constants. So that is equal to f of w, which is what? I erased it, but negative y times sine of wx, wy, plus x squared yz times now this, but this actually can be simplified to negative w over x.
What? Really? It really can?
Yeah, let me rewrite it.
Oh, man.
X from here, and you take out a w from here, and it simplifies to negative w over x. Do you guys see that? So then, forgot a W. So times minus w over x plus f of x, which is taking the derivative of f with respect to x, the partial. And do you guys want to say it? 2w xyz plus z cosine of x z. And this would be your answer. Yep, you can leave it like that. Any questions on this problem? It's just long. Part C, derivative of u with respect to x, this time holding w and z constants. So then we have the f of x plus f of y times dy dx, holding w and z constants, plus 0 plus 0, essentially.
C is supposed to be D over dy, or in the data it's supposed to.
Which one?
On the test, I think it says X.
It's du dx.
It is, okay.
Oh, that's an x, sorry.
Okay.
It was a very tiny. Since y is not a constant, we have that part here. And f of x, because rho x over, partial derivative of x over partial derivative of x is 1. So we can again do all of this step to find rho y over rho x implicitly. Or we can do it using the function theorem. For this one, I'll just do the function theorem. So, do you guys have this copied down? So we have to find partial of y with respect to x, holding w and z constants. That's equal to negative f of what? F of x divided by f of y. And that should be. So where are we? We're right here. Okay. Do you guys understand why is f of x over f of y? Because essentially you take the bottom x, like whatever variable is here, that's the negative f of that. We have a y up here, so it's like that. In the last one, it would have been x over w. So negative f of x, we hold everything constant except x. So here we would have a negative times 2xw squared plus wy divided by holding everything but y constant. So it's wx plus 2y. So that would be, we can take out a w, so negative w times 2w, 2wx plus y divided by wx plus 2y. And that is it for that. Do you guys see how easy this theorem is?
So you ever tell us to like not use that?
Yeah. Like in one of the problems, they told you to do it for 8a, they told you to do it implicitly, and then for part B, they told you to use the function theorem. So they'll do something like that. For this one, they don't mention whichever way, so you can do either. So we have the partial of u with respect to x, holding w and z constant. We had f of x first, and we found f of x for this anyway, so we have 2w xyz plus z. Hold on. Yeah, sorry, this is using the constraint, not the actual function. So this f of x that we had here is looking at the actual function u and taking the derivative, partial derivative with respect to x. So we get 2wxyz plus z cosine of xz. You guys see the difference? This f of x is different from this f of x because it's taking it of two different things. Plus f of y, which is what?
Negative
Yep,
W sine
negative w sine of,
WY.
Yep.
Plus WX squared.
wx squared z. Good. Now we need to multiply that by the, so here we had f of y times rho y, partial derivative of y with respect to x, holding w and z constants. So we need to multiply that now here, times what we found up there, negative w times 2 wx plus y divided by wx plus 2y. And that is it. You can take out like a z here and a w here, but you don't need to. Any questions on this one? So if you, in my opinion, if you have to choose between the implicit function theorem and doing it implicitly, use the theorem. It's like fill in the blank. You guys have this copied? And the last one is very simple.
Did you say no? Or just-
What happened?
Someone said no.
Oh, sorry. You're allowed to yell at me. Just yell out. Okay.
Did they say they were done?
So the last one is it's the simplest one. We have to find the partial of u with respect to x, holding w and y. What is the problem with this?
They're holding all of the variables in constraint.
Yep, so the constraint was w squared x squared plus wxy plus y squared equal to 5, right? If, let me try to think of it. We can't hold all of the variables in this constant. So if w and y are constant, and we're taking the derivative with respect to x, there is like, let me try to think. They can't all be independent simultaneously.
I don't know, if basically it has all of the letters and constraint
Okay.
in that thing?
What does it mean when it says?
Well,
Independent means hold a constant, but it also means other things, because, you know, we're not holding X constant, but it's
Yeah.
independent, so I don't know.
Essentially, you can't have the same three variables as in a constraint.
You have to have four
Okay.
variables.
Yeah.
If you had a
Um,
Z in constraint.
Because
say,
then that would, if a Z was in here, that means Z would be able to control the constraint to make it equal to a 5. But since all of them are independent, the constraint may not be true.
And you get 0 equals 5.
Yeah.
Or no.
So like we could have, if all these three variables are independent, we say then W, X, Y, and Z all might be equal to 0 because they could be anything. Then 0 can't be, then 0 would be equal to 5 essentially, right? So that can't happen. So you can't take a derivative of something in terms of three things when they're interrelated. That might be the best way to say it.
So do we just need to write undefined or do we need?
Yeah, so you can say equal to undefined. And you have to write this out for 2 points. W, X, Y can't be independent simultaneously. Since W squared X squared plus W X Y plus Y squared equals 5. Because this partial derivative is only caring about X, W, and Y, right? We're not even considering Z. So we can't have three same variables which are controlled by the same constraint. Because essentially, if this were allowed, we could then take leave W as under as independent, or not independent, but not a constant. Leave Y as not a constant, and then you can't do it with the same constraint. I hope I said that good enough. Essentially, if you don't understand what I said, you can't have the same three variables be in the same constraint, and those would like be. So if there was a Z here and we had a Z up there,
Still be bad.
it would still not work. Yeah, it would still be undefined. And that is it.
Good job, good job.
Good job.
No.
Did you make it into the video?
Yeah.
Good.
Of course.
We're blown